So what you have learned in complex number, first of all, you know the definition for the imaginary number I. So just say some definition. For complex number, we use a symbol, this one. For real number, we use this symbol. This is the set of complex number and a set of real number. For all complex number, normally we use the C to represent the complex number. It includes two parts. A and B belongs to real number. And A, we call it A is the real part. And B times I, we call it the imaginary part. And you know for I, we define it as square root -1. So this is the basic definition. So the application of complex number, it can replace a vector, the 2D vector, in terms of addition and subtraction only. And it can be also used in science, especially for physics, especially in quantum mechanics. So, what's the value of I squared? -1. I cube. No, I cube is I squared times I, okay? That means -1 times I is negative I. Huh? Huh? Is it already difficult? -1 times I. I squared is -1. Isn't it already difficult? You should quit, okay? You should quit.
Actually, oh my god.
Is it difficult already? No!
What's I?
Square root -1.
Oh, okay.
You have learned it. You have learned it. You have learned it.
We never, but we know.
Okay. Square root -1. Yes. For I to the power 4 is I squared times I squared. -1 times -1 give you 1. Okay. How about I to the power 5?
1i.
Yes, it's 1i. 1 times I is I. Okay? So you can see there's a period of 4. Period of 4. So, how can you write it? So initially it's I, and then if you times I, you get -1, and then you get -I, and then you get 1, and then times I, and you get back 1 I.
So I times I equals to -1. And then times I equals to -I. And times 1. Oh my god. No, man.
The lesson is recording, okay? Recording, and we will put into.
Yeah. How can he isolate his own voice?
Yes. How can I isolate your voice? If you can talk in ultrasound, okay, it cannot be recorded. So let's try I to the power 97. So you know that 96 is a multiple of 4.
So equals -1. It equals to I? Huh?
Yeah.
96 is a multiple of 4.
Yeah.
That means I to the 96 is 1.
Oh, okay. Yeah, okay.
So this is the beginning of complex number.
We're actually dumb.
let's go back to some easier stuff, okay? So in terms of this notation, okay, the real part we use a symbol, this one, okay, to represent the real part, we call it A. The imaginary part, we use this symbol IM and give you B, okay, without the I. So just give you a, not a challenge actually. If the imaginary part is 0, that means this number is a real number. Okay. Or you just say Z belongs to real number. This should not be difficult. Imaginary part that is B is 0, then this is a real number. If you look at the textbook, but don't need to look at the textbook.
So what is that symbol?
Yeah, belongs to real number.
Oh, okay.
Have you learned this symbol in core math?
Yeah, but I forgot. I think
P1, primary 1? Okay. I'll go back. Next. Sometimes we need to express some of the sets in terms of imaginary number, just like this one. You know from 6i. Another example is negative 20xi. Negative square root negative 20x. Then it can be written as I times square root 20x. How do you simplify square root of 20x? Okay. And then, or just use your calculator. The new one, okay? And then, you know how to turn it into complex mode. And menu, okay? And then second one is a complex number. You should buy a new one, okay? Better to buy a new one. No, not hard selling, okay? You need to turn it into the complex mode first, okay? And then when you press it, the square root negative 20. No, you can't.
This complex number can just do its mode to.
Yeah, I know. Then how can
So buy a new calculator. I really suggest you buy a new one. If you need to take this, because you need to. There's some question you need to use differentiation and integration later on. Yes, we really need a new calculator. Okay.
So actually we can use statistics because this calculator gives us all of the.
But just see if you find statistics boring or not.
It's boring, but we don't have lessons. Because if we know how to do it with calculator, we don't.
No, you need to know the concepts. No, it's not that easy, statistics. Now, to do the addition and the multiplication of complex number, for addition it's quite simple. A plus bi, and then plus or minus c plus di, and then just what you do is just consider I as an unknown. Okay, 1 plus 2x plus 3 plus 4x. You know how to do it. Simplify this one. So in this case, it's just the real part is a plus or minus c, and then the imaginary part is b plus or minus di. Okay. Just like what you consider I is a unknown. So just give a very non-challenging question. So -2 plus 2i, okay? You find it difficult, you should leave now, okay?
Don't say that was the first yet.
He wrote it.
Oh my god. Let me do it myself first. Let me do it by myself. There's no way I can do it.
Is it difficult right now?
Just the first
should-
page of the first chapter.
You should leave now, okay?
Got it.
So if there is a constant outside, okay, you just do the same thing as you consider it as a unknown. Okay? That's simple. If you understand it, you don't need to copy it because it's so simple. So I'm not. Actually, we have finished the textbook 1.1 already.
Oh.
Yeah.
But there's 1.8.
Okay. Let's go to the next part. Okay. This part is so easy.
We're not going to do any.
You 1.1 no need to do exercise, is it? It's so simple. You do it at home, okay, by yourself. So let's go to the next one. Easy? Now, but if we say that A plus BI equal to C plus DI, and A, B, C, D belongs to real number, and then A should be equal to C and B should equal to D.
Yeah.
Okay?
Yeah.
Okay, and then we finish that part, and then we go to Oh? I. Okay. I'll go to next page here. And then for next one, just like for solving some of the equations. For example, c squared equal plus 9 is equal to 0. And then how can you solve c? Just put the net 9 on another side, give you c squared in length is 9.
Yeah.
So c equal to square root negative 9.
Yeah.
3i, okay? Simple. Another example is about the quadratic formula. I hope you can remember the quadratic formula. Okay. What have you told about if the discriminant is smaller than 0? No real roots. So, but if in this in third pure math you have learned about the complex number, so you better say that two distinct complex roots. No. Complex number, okay? The roots are in complex number. That's complex roots. That's the chapter out. This is this chapter. Can you give an example of discriminant more than 0? The easiest one. Okay. You can check the discriminant in this case. -3 smaller than 0. So if you use the formula above, -1 plus or minus square root -3 over 2, okay? And then you get the final answer if units of I. Oh. If you have a new calculator, you will directly given you the answer in terms of the short square root form.
What?
Yeah. Yes.
So what does it tell you? What's the component?
Find the roots, the complex roots.
So you discriminate and then you find out the small that zero, yeah?
Yes.
And then what? And then you use like,
The quadratic formula, and then you can find the roots.
and what's the point of like the discriminant?
It's because it's complex number. So, no. I'll just let you know is the screen is smaller than 0. Okay. Huh? It's difficult now. Is it difficult now? This is what you have learned, but there is just a square. There is a negative inside the square root,
Yeah, it's right.
so it should not be
Yeah, it's
that difficult.
no man, don't do like that.
Actually, the main problem is that you did not have additional math last year, so the math level is not.
Yeah.
So, can you do this example by yourself now?
Oh yes, we're going.
In textbook, it told you about two methods, completing square. Okay, forget it. Just use the quadratic formula. Just use the quadratic formula to solve C. 25 are here.
Wait, but we need to write the steps.
Yes, in exam.
So use the B square minus.
Negative b plus or minus square b squared minus 4ac over a.
I forgot that formula.
No.
Wow, okay. Using core math có hay đọc.
Who said?
I say.
Oh, it's a nice number. What's your answer?
It's negative 3 minus 4 and negative 3 plus 5. You split this.
So it's negative 3 plus or minus 4i.
Yeah.
Take out the C. Oh, yeah, 2.
And then you can go back home to do some exercise in your textbook 1B. I just announce those exercises, okay, through the group. So we finished 1.1. Let's go to 1.2. In this textbook, there are only 6 chapters, is it? No, 8 chapters.
Are we doing one day one?
Hopefully, I think.
Yeah, there's 8 weeks.
Which is? Oh my god.
But we have 3 units, you know. We have 3 units. So let's go to 1.2. 1.2 is multiplying the complex number. Multiplication.
Isn't that what we did right now? Complex
The one chapter.
Huh?
So we're gonna finish chapter 1.
Yeah, should.
You should.
That's for real. So we're doing chapter 1 today.
Like,
I'll give you this multiplication. So I'll give you a general case here. So what we do, just consider I is an unknown. Just consider I is an unknown. So what you do in this case, you have learned it before, okay? And then just remember I squared is negative 1. So the final answer should be AC minus BD plus BC plus ADI. I'll buy a breaker screen.
Just use the computer monitor.
No, I can't record the lesson if I use that Apple TV. No, because I've tried this before, because the iPad uses the same CPU to record the lesson or Apple TV. You can't do two things together.
I have better CPU.
Yes, huh? Huh?
You're rich.
No, comparing to you, okay? I'm nothing.
You think I'm rich? I only have $500 per month.
Whoa, so much. I get nothing.
For lunch and transportation.
No, I don't get money from my parents
Salary.
every day, every month. I get zero. I get negative, do you know? I get negative money.
Liquidity problem.
Minus PG.
I times I is -1, okay? I times I.
What's the thing between I times I?
I times I is I squared.
So is it
I
negative
equals
one?
I is I squared, so like it's negative one.
Yeah.
Yeah, that's good.
Let's do an example by yourself, okay? Don't use a general formula in the above. Do it by yourself, okay? Just ignore the general formula. Times.
What do you get?
If you, it's better for you to calculate it by heart.
I need
If you can.
stats, hello?
And you can also check your answer with your calculator. Do you know where is the I?
Yes.
Yeah.
I'm here.
English.
I am here. Okay.
It's under English.
Yes.
Wait, so the
I am
equals
here.
five.
Hmm?
What? I is here.
About 10 plus 5i.
Hello.
Oh, yeah.
Okay.
So, actually, okay, so.
Now let's do another example. Okay. How about 1 minus I squared?
Oh, is that a question?
Yes. One minus I total square.
What do you get?
I'm lazy. You do it so fast?
You should use it by,
Okay. 2 minus 2I. Haha. No,
no,
it's not 2.
It's not.
It's 0 minus 2I.
Yeah. Because I squared equals to negative 1. 1 minus 1 is
Yeah. He's so smart.
no.
Smarter than me.
Still, but it's negative I squared.
No, but your name size is 8.
So this.
So it's negative plus 1.
Yeah, y e.
Now actually in this question you can use this identity. You should remember.
Yeah.
A plus B total square. A square plus 2AB plus B square. Do you remember this formula? HS, okay.
What?
HS.
Oh.
Then in terms of algebra, you need to remember these formulas.
Different square.
How do you simplify this one? Hmm?
Because when it's classical, it's minus. Yeah.
Hmm.
Same thing we just did, but
Wait, serious guy. So
Trong cái lần này
Recording. The principal may watch it.
Yo, sir, it's not swearing. Wait, it's actually a slur. I keep on hearing like patterns.
But what is that?
Hmm?
Man, let's see what.
It means that when here is plus, here is minus. When here is minus, here is a plus sign. It's not the Chinese word, okay? Then we have finished 1.2. Okay. Next one.
No, I'm saying home tonight. Must study very nice.
How to start it off.
This is the easy part, bro.
Oh my god.
No.
Game à?
The easier part is really, really easy.
Is this the easy part?
One of the easiest parts.
One.
One of the easy parts.
Okay, compare like ratio easiest parts to like just tell. What's the ratio?
The mechanics one is always also quite easy.
No help.
So for complex conjugate,
Complex conjugate.
so the definition is this one. If C is equal to A plus BI and A and B belongs to real number, okay? The complex conjugate, you just put a star on the right top of the number. This is the complex conjugate of C. Oh, shh. Shh.
It's recording.
It's recording.
Principal, that.
No. I'm not trying. Maybe, just say maybe. There's still a probability that he can search my YouTube channel.
Oh no,
Just make the imaginary part be negative. Oh.
Can you say again?
Just give you some example.
Oh, okay.
Just like when it's 1 plus 2i, the complex conjugate is 1 minus 2i.
So
When it's 1 minus 2i, and it'll give you 1 plus 2i.
Only imaginary.
Yeah, only the imaginary part become negative.
so you have to draw the star like that.
Yes,
Wait, is it a must?
must. Here, like this one.
Oh.
You can't draw the star like this, okay?
Oh,
oh my god.
You get 0 mark.
oh no.
Follow the symbol. In some of the textbook in mathematics, they write the symbol of complex conjugate like this one, a bar on top of the number.
Wow.
No. In complex number, it means the complex conjugate.
Why is this so complex?
Sir, can you draw one more slash?
No. Follow this symbol.
Gabriel, okay? Yo, sir, that's simple.
I'm not Gabriel, I don't.
La. For all, have you seen this symbol? For all C belongs to complex number. Complex conjugate twice, okay? We give it equal to itself.
Yeah.
Just negative and then negative again. And then give
What
you
is the upside down A?
Simulate.
for all. Is the here, for all C belongs to complex number. This one is true.
Why so complicated?
Is that a question?
Because a mathematician don't want to write so many words. They are lazy, okay?
So that upside down clock is for all.
Yeah, this one symbol is for all.
For all Z in C.
All.
Oh, okay.
The long.
Sir, do we have to know that? Like,
Yes, you need to know it. Even in your core math exam, you use these kind of symbols.
Yeah, so we have to write the upside down A, Z. Like we have to write out the, like you have to know what the
For general theory, they always write down like this to tell you that it's true for all complex number or real numbers. So if C equal to A plus BI, and then you can check by yourself, okay? A can be written as C plus C star over 2. Don't be amazed right now. No. Let's prove it, okay? Let's prove it. Let's prove it, okay?
That's for A. I should understand.
In this case, you're
No.
just gonna cancel out the imaginary part.
Let's prove it, okay? A plus BI plus A minus BI over 2 give you 2A over 2.
You're gonna get a C4.
Give you A, okay?
You don't want to drop the subject too hard.
Over 2. Over 2 here. Not.
So A is always like that.
Yes.
What's B?
Although it's not in the textbook, I'll just give you this one. This is not difficult to
So A
understand.
is always like that. A equals
Huh?
to that.
A equal this is. But it's.
Shall we do some practice?
Yes, later on. So C minus C star over 2I.
Wait, go back.
You look at your class-based one. Hard. You think it's difficult right now?
Yeah.
I don't know.
No, man, like.
B R 減 B R 嘅嚟
Huh?
B 加 A 嘅語物
If you take concentrate, like concentrate.
Oh. You substitute by yourself, and then you can get the answer by yourself. Actually, you can prove it by yourself. So let's go to the next one. Oh, actually, it's very small in terms of the whole page. Okay. Hmm?
Oh, it's actually easy.
Hmm? Hmm? Now next page lah. Lại.
So Z equals to A plus BI. Always.
Just a symbol
Yeah,
here.
okay. Oh, it's actually easy.
There's another things you need to know about. Sometimes you are asked to write down like this one, okay? 5 plus 4i over 3 plus 2 minus 3i in terms of a plus bi.
Don't you just do times the denominator?
So just remind you what you did before in this kind of question. How do you write this in terms of
Times 1
a plus b square root c, something like this?
times 1 minus square
From
root of
1 minus square root 2. So I is square root minus 1.
Yeah.
So you use the similar skill here. You still remember how to do, we call it rationalize, is it?
rationalize.
Rationalize
So
this
you
one.
times 1 minus, so 1 negative square root 2.
Yes. So here, in this case, we multiply by 2 plus 3i, okay?
Yeah.
The complex conjugate of this one.
Okay.
And then you do the multiplication on by yourself. Try by yourself, okay?
So we can just leave the bottom before.
Hmm?
Can we just cross out the bottom?
Hmm?
Well, actually, no.
For the bottom, it's just like a minus b times a plus b. So give you a squared minus b squared. 2 minus 3i, you can just consider is a minus b. 2 plus 3i, you consider is a plus b.
So I got.
So after you simplify this, is a minus b squared. Do you still remember this formula? So at the bottom, you give you 4 minus 3i total square. That's negative 9. So the final answer,
Negative 2 and this is 2.
and also of course you can check with your calculator. Use your calculator to check it. Your calculator can do it. That's why I told you to buy it in the beginning of the lesson. Okay?
Add square root to negative 1, yeah.
We finished 1.3. Not that hard. You need to do some exercise in 1D.
Oh my god.
In the textbook, okay? You should do some exercise in 1D. So to check if you can practice, understand these stuffs. Food? Or you can use photosynthesis. Make your own food.
I get 22, but I will get 2. I will get micro. How do you get this?
I didn't have money, I didn't have bread.
2 squared. Eat your.
This equals 13.
Let's go to next one.
Oh. Oh, okay, yeah, okay. Shut up, man.
Huh? Next one, okay? Exercise 1D.
1D.
Yeah, you need to do of you.
Oh, question.
You need you choose by yourself. Let's say all of them lah.
1D now?
Hmm?
Not now.
Later. We go to the next. Do it at home. Do it at home. You return time for you to do homework during the lesson.
Yeah.
Yes. Okay, keep going.
So 1.4 now.
I. Do you know where we find the I? Here, English. Actually, I don't know what does mean by eng. No. You can represent the complex number in a xy plane.
Yeah, this will, what chapter is this now?
1.4. We can't teach as slow as your class in core math, okay? Because oh,
I got 100% my test.
Yeah, it's only a test. How about the other test?
Yeah, every test I got.
Also only
the x-axis represent the real part, and the y-axis represent the imaginary part. So, if you have a complex number in the form of x plus yi, and then in this graph, these points represent this complex number. Okay? These points represent the complex number of x plus yi.
Wait, so that point represent.
The x plus yi.
So because it is z.
Yeah? The complex number.
Okay.
Yeah, the complex number. So just like when you say this, maybe let's just say here's 1, negative 2, and then this represents the complex number 1 minus 2i. Okay? When you see this, let's say here's negative 3 plus I, just not in scale here. You have this is a coordinate with x coordinate and y coordinate. You know how to draw it on the xy plane?
So what's this?
Maybe I will wait.
No, you should chop it. You should chop it for a few minutes. You really should chop it.
Oh, minus 2? Oh,
You know this is a junior secondary.
yeah.
Even in junior secondary, you have learned the coordinate system, xy coordinate. Yeah, okay. And also, you have learned before about the vector. So, this point, if so,
So
how it can be represented vector? In terms of vector, okay, this vector we call. Have you learned this form of vector?
yeah.
The column matrix here. Column matrix.
Oh, yeah.
So this can also represent. Complex number can also represent a vector in form of it. No, it should not be difficult, It's an example from your textbook. You can already find a typo in your textbook, okay? Although this is a very new version. Can you see it? There's typo. There's 1 plus vi. Oh no, it's not. Oh, not a typo. Sorry. I.
Challenge. Only I can challenge.
Yes, he also always challenged the principal. So, represent this one in terms of C1 and this C2. So, how can we do why we sometimes represent a complex number in terms of vector? Because the addition and the subtraction of the complex number can be considered as an addition or subtraction of vector. So do you remember how to do the addition of vector? You use triangle rule or parallelogram rule. So the addition of these two vectors is here. Is it? Later on, you could try to draw the graph and then see it give you the same result.
Are you gonna send this recording to the physics class chat?
You're not in.
Oh,
Yeah, I was down here.
Someone just add me in.
Yeah, you're Mr. Yu.
Yeah, oh, it's missing.
You look at the example by yourself at home. Okay, example 11. It's doing the subtraction. So actually, it's quite similar. And we finished this already. Haha. Let's go to 1.5.
Wait, don't try that. Can I go to the bottom? I'm doing good. Don't start it.
that's literally the same as any important.
So for next one, it's about the modulus and argument.
This is the x which is the y function. Y is imaginary, so it's like this is real, so it's a real number.
Oh yeah.
And this is the same. X is real number 2. Y is negative 3, so negative 3. X is negative 4, real number 4. Y is 1.
So you're using box at time.
And you can have it color box if you want. But you can combine the lines together. You'll probably get 7 on the best. Say,
What is that?
these two. Oh yeah, what's it called? Discriminant matrix.
So, so this one is the modulus of the C. You know why we use this later on. Just like when we draw this vector in the Argand diagram. So here is A, this is B, and then this vector or complex number is A plus BI. The modulus of this vector this complex number is just considered as the magnitude of this vector. Is you use the Pythagoras theorem. So you get a square root a squared plus b squared.
So you can find vector.
Hmm?
So you can find it vector.
No. You can check, okay, by yourself, okay, because it is a homework. The most dearest square is itself times its complex conjugate.
How?
You try by yourself.
Oh, that's
Just check it. So next one about the argument. Okay, the modulus must be a non-negative number, okay? Because it's square root. Hmm? And this is a real number, it's not a complex number. The modulus, just a magnitude.
Magnitude must be real number.
Yes, real number. Scalar includes real number and complex number.
Is that why there's stars up there?
Complex conjugate.
Magnitude needs to be a real number.
Another thing about the complex numbers are the arguments of the complex number.
So really it's just certain
We use ARG, okay? Don't mix up this symbol with, you can't write the A as a big A. Let's represent another thing. Also argument, but they have some slightly different definition. I think you don't need to know it later on in further pure math. I forget. This one is actually the angle measured from the x-axis. Anti-clockwise. So I'll give you some example to understand this one. And also you need to express this in terms of radian, not degree. Or first you can express this one in degree, but it's not common practice in mathematics. So I'll give you some example, okay? Just like if you have a complex number is 1 plus I, okay? Then what is the angle here?
Oh. Tangent, then I.
In terms of degree, what's the angle? Angle in degree. 45 degree.
Oh yeah, it's 1, 1.
1, 1, okay? So this is a isosceles right angle triangle, 45 degree. Then there is pi over 4. And why I call it is anti-clockwise? That means,
From axis.
yeah, from x-axis. And anti-clockwise, you take positive. If it is clockwise, you take negative. So the argument for 1 plus I is pi over 4. How about 1 minus I? 1 minus I is at this point, okay? 1 minus I.
There was
going to be 360 minus.
it's pi minus 3.
So it's negative pi over 4 because it's clockwise from x-axis, the angle. And this angle, okay, this angle, we define it in between pi and negative pi. This should be bear in mind, this one. Why it can't equal to negative pi?
What do you call it?
Because that's 180.
So if you consider negative pi, it should be measured from clockwise, okay, from here to here.
Yeah.
So it's just equal to pi.
Yeah.
Yes. So but in mathematics, you can just have one unique number. So we choose it to be positive pi. You can't say at this point it's negative pi or positive pi.
Yeah.
We just choose a number. We call it, just say it's positive pi. Okay?
So, hey, I was a bit late, sorry.
Okay? Uh, in terms of quadrile, this is the first quadrile. Well, this one is the first one, is it?
No, the top right is the first one.
1, 2, 3, 4. Why is defined like this?
No idea.
1, 9.
Because in terms of polar coordinates, the angle is measured from x-axis anti-clockwise. So it's starting from this region, 1, 2, 3, 4.
Okay.
Polar coordinates.
Mm.
So I'm going to.
So in this region, in region 1, the angle, the arguments should be within 0 to pi over 2. Okay, positive. I don't say equal because it's just in the x-axis or y-axis. Hmm?
If there's something related to sine, 19 plus pi is equal to. Pi over 2. Oh, we have to remember this, or it's just like extra.
Argument is not extra, you know.
No, like the 1, 2, 3, 4.
Huh?
But you should know.
You should know it in core math also.
No, but we know.
Yeah.
Why is it negative?
What is that?
Why is negative pi? Because the angle argument is measured, if it is measured clockwise, see, from x-axis, you take negative. And the angle, do you remember the angle argument is within pi and pi, negative pi and pi. So I'll just give you an idea in which region it will be in that range. Okay? In your textbook, it's quite confusing, but
So sector 1 and 2 use positive pi,
mhm,
3 and 4 use negative.
mm.
Okay. Use that in your
Wow,
answer.
page 12. Let's just stop on here. We started using music.
Only for 180.
Yeah, negative.
So hard right now?
So this is from negative.
Does that mean in our answers we have to use negative pi? If it's
Yes.
Oh.
So,
Hmm?
so this is 0.
Can't see it. I can't see it. It's not bright.
Sector 1 and 2 use angle. If the other one use
Let me talk about a few of other identities. Okay, although you may not need in exam, but these identities may be useful. Hmm?
It's like if you're taking the magnitude of z through power, then this raised to the power of n anyways. So what difference does it make for the last example?
No.
Oh, just
Just an advantage.
okay.
So now you try to do some exercise at home. Especially for the argument. To find the arguments, it may be a little bit difficult. You need some exercise at home. So we'll go to 1.6 next time. 1.6 and 1.7, okay?
What are we leaving now?
Yeah.
Well, can we finish now? Can we just finish?
No, there was 1.5. It's just well, it's just 1.5. Argument 1.5. Argument 1.5. Wait,
You
did we
ask-
finish 1.5?
You ask him, right? You ask him.
That's what's 1.5.
So,
Oh, yeah.
can we go on? Can we go on? Go on?
Wait, I watch it.
Let me. No. Just finish it first, and then you can go. Maybe I'll give some example about the argument. Okay. Just give you 4 example. For example. No, how to find the argument? Just I don't draw the graph lah. Well, I should better draw the graph. So for example, here is 4 plus 3 plus 4i. How to find the argument? Tangent. It is arctangent. 4 over 3.
No, negative tan to the power of negative 1 is
Tangent opposite
No.
Oh, so you just don't consider the eye?
Yes, because it's just the sign is 4 and 3 here. Okay.
is tan to the power of negative 1.
Yes.
tan.
tan negative 1.
Remember, you need to use radian.
Okay.
Oh no.
Or in mathematics, I think you probably need to just use 3SF. 3SF. Okay? In radian, the argument is 0.927.
For physics, significant figure is so much more popular.
So what's argument degrees?
The angle from x-axis
From x and
in radian. In radian, yeah.
oh, okay. I know argument.
For next one, in this case, the argument is the angle in this here.
Oh, so you should minus the angle.
You can do that, but I'll give you 2 different methods to do it. Okay, wait for me.
I'll just do the angle.
Wait for me. So if you consider it's a right angle, what you should do? Just say here is theta, okay? The answer should be pi minus theta. Oh, it's not. It's arctangent, okay. Then the answer should be 2.15, 2.16.
Wait.
There's 2 ways to do that.
Oh, so that's the first way.
Oh, another way. It's a little bit difficult. Because in your calculator, the value given in your calculator is from, when you do the arctangent, the value given in your calculator is from negative pi over 2 to pi over 2. So it does not give you this kind of answer. So better do it in this way.
Like this. So always harmonize or do that.
Arctangent a positive number. And draw a graph to help you to find the angle. Example 3. Get a easier one, okay? 1 plus 1 minus I, okay? So it should be negative pi over the 2. No, pi over 4. Negative pi over 4. You measure the angle here, okay? And take it negative. Because clockwise. Last example. You need to do more practice in finding the argument. Just consider to find the positive angle, the angle here, okay? The positive angle. Then the theta here should be arctangent.
This way, underneath, you have to go that way. That's opposite of anti-clockwise.
It's negative for sure.
If it's always from here.
Now it's 45.
1, 1. Triangle 1, 1, 1. Triangle 0.
So after pay also makes you carry negative. Oh, so you always take negative there. Like if it goes down, it's always negative.
So if the value is below the x-axis, it always negative. So here the angle is pi minus theta, but the argument is negative value, okay? Negative brackets minus theta.
Negative part.
So I think you better draw a graph by yourself, okay? And then to help you to find the angle. It's easier for you.
4 divided by 3. Pi minus n. So it's negative 2. What?
So you may think it's quite nonsense to write the complex number in this form, to find the modulus and argument. But actually, in some of the cases, especially to take the power, it's easier in terms of modulus and argument.
Isn't the modulus like find the remainder and like yeah, mod 37 is 1.
No, if you two lines, okay, two vertical lines, inside is a real number, we call it absolute value.
Okay.
If inside is a vector, we call it magnitude. If inside is vector, it's magnitude. If inside is a complex number, we call it modulus. They,
Another modulus, isn't it like 7 mod 3 is 1?
oh, MOD.
Yes.
Yeah, that's also called modulus.
Yeah.
that means remainder.
Yeah, the remainder.
Oh, Oh, we need to use the school.
Please note that school will close at 5:30 for all students. We have 5 minutes for you to exit the school grounds. All students, please leave the school by 5:30.
Okay, we go. We finish it on Monday lunchtime. Monday lunchtime. You bring your lunch box here. If you have one. If you have one. If you bring if you buy the lunch and bring here.
I don't know how. I mean, how sure?
Oh wait, but they just are.